I'll just change my setting of this bitrate, or else it will create a issue. Mm, 2498. Refresh this. Audio bitrate 228. Uh, Audio. So today we'll going to do some stuff related to Heap Overflow. Okay? Like first we're going to check like how the Heap works, and then we'll exploit a bug which is known as UAF bug, which is called as use after pre-bug. So we'll just try to learn from that particular content today, and I will try to solve. Okay. So I just drag this over structure down. Use after PLS, or also I can open my uh, window here. So as you can see over here, I've created this C program. Okay. Now as you can see, I'm having the win function over here, and the target is to call the win function, and we are having the driver code over here, which is the main function, right? So in that, I'm creating the three pointers: pointer one, pointer two, and pointer three. So pointer one is allocating the 8 bytes onto the malloc, right? The heap data, and then I'm printing the address of the pointer one, and then I'm again trying to bring the pointer one. Okay, and then I'm doing some stuffs related to taking input and all, and then again I'm trying to allocate the pointer two and three, and then again I'm trying to copy something onto the pointer three, and then again trying to do some alloc. So basically, this particular file actually uh, tries to make, or we can say it is trying to do UAF work, which is use after free work. So what happens into the use after free bug is that, so basically you try to allocate memory onto the malloc, right? So as soon as you allocate memory on the malloc, right, the heap, so it gives you the pointer back, so where the data has been located. So what happens is that, so whenever you try to free that particular memory, right, by using this command called as free, okay, so that pointer gets freed, but in actually the pointer is still pointing to that memory address. So after that, whenever you try to re-choose this pointer, we can write to the return address or the next address of that particular pointer. So this will be like a very bit, not tricky part over here, but I'll show you all uh, on this. So there is a particular layout for that. So if I say heap overflow layout, right? So it is basically we are trying to overwrite a particular pointer, okay, over there. So we write the pointer of the bin function over there, and as soon as we call malloc again, so it will going to point to that bin function, and then we can get the bin address executed, right, throughout the stack. So for this, you all be needing the same tools, right, which I've used in my previous video, like for example, the GDB extension with the pond debug extension, and then the Docker environment and the GCC compiler of it older version, right? So over here, I've created this, code, but for your purpose, what I'll do is that I'll try to, create a new code for this. So what I'll do is that I'll create a new directory called as yt heap 001. Okay, so I'm in this. So now what I'll do is that I'll show you all my Docker images. Okay. Oops, sorry. So now as you can see, I'm having already my heap lab and environment, right? So I pulled this Docker. So the reason I pulled this Docker is that it is running a bit older version of Ubuntu. Okay, so the bit older version of Ubuntu, in which we can try to export that particular heap, well, that particular expert, because in the older versions of Ubuntu there is a older version of glibc. So glibc is like you can say like glibc. So glibc can, sorry. So basically, it is a GNU C library, a fundamental C library implementation that is used in most of the Linux distribution. And this particular glibc is also responsible for like for the actual code of malloc.c, then free.c. So it contains that code. Okay, and there are many ways of allocating data onto the heap. So there is a concept called as the package bean, the free beans, and there are much other stuffs. Okay, so what I'll do is that I'll try to run this Docker. I'll give the name of the Docker as heap lab environment, and then I'll give the volume as my current directory, and then hyphen. I guess it is best, right? Okay, okay, okay. Into the home directory. Take this space, right? Being best not found since. Let me check the command. You can use the space. Sorry. Wait, I thought it is search. I've created my notes over here. Heap attacks, use after free. Slash bean slash or search. But I gave this, but it didn't work. Okay, we didn't specify the name. Just bean slash or search. We can search. What am I missing over here, right? What am I missing? Sudo docker. I need to recreate this docker, I guess. Got it. I need to copy the configuration Docker file, I guess. Yeah. Oh, yeah. Sudo Docker build tech t pnv pnv this. Yeah. And after that, I need to create this, right? So that. Okay, no. Yeah, so we are okay. So now I'm in my Docker container. So now what I'll do is that I'll try to. So currently I'm into my same directory. So I can create the vulnerable C code, and then I'll just try to do the stuffs which are trying to do. So what I'll do is that I'll create a file called as touch main, or I say one.c. Okay, so now, as you can see, I'm having this 1.0. So now I'll try to write to this file. So what I'll do is that I'll just try to come back to my Heap workflow. And again, I'll just try to open this file. Okay. Oh, sorry. Uh, right. So I just try to include my files. Then I'll just try to do hash include string.h2. Um, hash include std lib.h for mallocs. Name, sorry, not tab over here. It's name. So what I'll do is that I'll first try to do some allocation onto the heap, right? So void pointers, pointer one, star pointer two, star pointer three. Okay. So after that, I'll just try to malloc 8 bytes onto the heap, right? So pointer one contains the malloc 8 bytes. So so basically it will going to contain the pointer of that particular malloc set, right? Then what we're going to do is that we can try to free out this pointer. Okay. Oops, sorry. So we are trying to free out this pointer. So I'll just say pointer one. Now the particular exploit will come over here, because after doing free to the pointer one, we cannot try to use this pointer in other or the future part of the code, because now this pointer is called as the dialing pointer. Okay. If I'm not able to pronounce this correct, so it will be like DALI dialing pointer, dialing pointer. So yeah, so a, a dangling pointer is a pointer that no longer points to a valid or validity allocated memory location. So it is called as a dialing pointer. Okay. So this, but in this case, we'll try to use this pointer and we'll try to override to this pointer. Okay. But now what I'll do is that I'll try to implement it within my particular C code only. Okay. So now what I can do is that I can try to write something towards that particular pointer. So I'll use star copy. So I want to write at pointer one, and I'll try to write 4 bytes of A. Okay, the classic buffer overflow which we use, right? To overflow the stack canary or the, sorry, the return pointer, right? And that's all. And then what I'll do is that I'll just try to yeah, that's all. I'll just try to even also write the data part. Okay, and then what I'll do is that I'll just try to do return 0. Okay, yes. So now if I change my terminal back to this, so I need to compile this, right? So what I'll do is that gcc vuln.c hyphen o 1. And then if you all want, you all can give the tag called as hyphen g. So basically, it will. So whenever if you are trying to debug back it into the GDB, right? So what will happen is that you all can easily try to debug it with that particular source code file. So it is much easier. But I would recommend for you all just to go with this command. Okay, we are having some errors okay over here. So let's solve this errors out. We can see retur, but sorry, my bad. And integer means sorry. Mm, let's let's try to do now, and it has been already compiled. So if I do one, it nothing happens, right? But now we'll try to debug this using the GDB. So what I'll do is that, so now first we need to okay, now there is a very main concept over here. So now I have compiled this binary into my Docker, right? So now it will going to contain some uh, uh, libc file and the runtime code, because I have compiled it with non-static. So if I had compiled with like hyphen s flag, or it is called as the hyphen uh, static flag, so the binary size will be large. So now I need to copy that, well, particular G libc version into my host version, right? So now to check the linking of that particular file, there is a command called as ldd, and then you can give the one over. So now we can see that the libc.so.6 is pointing to this directory, and the ld, the linker libc file. So we need to get this, both of these, into my particular host system. Okay, so now what I'll do is that I'll just try to copy this whole stuff, and we'll copy this, and then what I can just a second. Okay. Okay. Yeah, so what I'll do is that I'll just try to copy this libc, okay, to my current path, and also try to copy my ld, which is the linker path. Okay, so I'll just try to copy this over here. So now if we see over here, which is the, so now we can see this ld and the libc. So now what I'll do is that, so I need to patch this vol binary whenever I run it on my host. You see that it should link it with this particular two binary. So there is a command called as patchl. Okay, if you all don't know, so it will going to patch this binary, okay, with this particular libc and the ld. So now what I can do is that I've already created this file. So in my use after free, there is I guess it is in use UAF2. Okay, yeah, there is a patch.sh file. Okay, so I'll just try to copy this, okay, over here. And now if I do nvim patches, so we can see I'm trying to run this command as sudo patchl hyphen set interpreter to the glibc slash ld linux x64, so the name of the linker, and then I'm trying to also set the r path, which is the run path, right, with the glibc. So any binary this particular program wants, it will going to first search into the glibc, right? So what I'll do is that I'll currently remove the glibc because I've not created glibc folder. So I'll just create dot, stating that it will going to set our part with the current directory only because I'm having all the files over there. And this also over here to ld Linux x6864.so.2. Okay, so now I can just press escape wq. So now before running this command, what I'll do is that I'll just show you the LDT of the vulnerable binary over here. So now it is pointing to my current glibc version, but I don't want that glibc version because I'm trying to do the heap overflow attacks of it older versions. Okay, so I'll do patch all. Oops, sorry, not patch all. Patch.sh undo root. And if I do now LDD on my vol binary, now we can see it is pointing to my current directory. Okay. Mm, this is not the word which I wanted to do. Let's try to do it again. Okay. What I try to do is that set interpreter to okay. I forgot to give this dot slash, right? So now if I try to do with this patch, right? And if I do LDD, so now we can see it is pointing to this particular same directory. Okay, well, so now the first thing is that every time you compile the binary, you all need to link this again and again. Okay, now if I see over here, if I try to run this binary, right one, you can see it does nothing. Now what we'll do is that I'll open one more terminal over here, desktop. I guess it is in learn heap and into my YouTube Heap 101. So I'll just try to load my GDB, right? So the GDB and the name of the binary, and I will give it as a root. Okay. So now I'll try to do info functions. So if you all don't know like the commands of one debug, okay, or the basic GDB commands, right? What you all can do is that you all can go to my playlist, and over there I've mentioned one for like talk based on introduction to assembly and interactive video. So over there I've explained this particular commands which you all need to do. So now what I'll do is that I'll set a breakpoint to the main function. Okay. Main function is not there. Okay, over here. So what I'll do is that I'll type start. I think I've messed up with this. Okay, this is a bit weird. Let's try to debug this. Okay, I don't know why, but this is very weird. Is it because of uh, not valid patch help? Okay, what I'll do is that I'll make a directory for glibc only and move the LD and the LD to glibc. Uh, libc to glibc version over here. Okay, so I'll just try to remove these patch checks and again copy it from my UAF to patch s.sh. Now if I do LTD, not a dynamic executable, so I need to compile this again. Okay, just try to compile this again over here. If I can G plug. So not this. So if I do, yeah, so it is pointing now back to this current gdpc. Okay, it executes properly. So I'll go to this main function, and instead of I will give I will give hyphen g flag for debugging it. Okay, I guess it's over here, right? Oops, sorry, q, my bad. Info functions start. Yeah, so as soon as I click on start, it adds the breakpoint to that, the entry point of the main function, right? So now we can see that we are having the pointer over here, the pointer one, right, in which I'm trying to allocate the eight bytes of data. So as soon as I do ni, which is the next instruction, right? So if I do ni, so we can see that we are about to call the malloc over here. So as we can see, and we are passing the argument in edi, which is the 8. So 8 bytes. So as soon as I do ni, the malloc has been allocated successfully. So now how to check, right? So there is a command for that. So vmap. So if you all type vmap, we can see the heap which is denoted in the blue color, right? So we can see the starting address and the end address. But now to visualize the heap, right? So point debug has a very beautiful, command called as viz heap chunks, or you all can even type vis and hit enter, and then we can see this whole part of the heap. So this is the data which we allocated over here. Okay, and this is the top chunk which is pointing to the top chunk, like the data which is more available onto the heap. And this is the metadata of the heap, in which heap chooses to store its pointer. Okay, and every kind of that kind of stuff. So now as you can see, so if you type tkh beans, tkh beans tkh beans, I can say, right? So currently tkh beans is empty. So now what is tkh beans? So every time when you allocate some pointer, okay, oh sorry, some data onto the heap, and whenever you again try to delocate it, like whenever you try to free that particular data or pointer from that particular heap, so so that part of the data goes into the tkh beans. Okay, so there is a concept called as tkh bin. So that particular pointer has been pointing to the tkh bin. So next time whenever we try to allocate again 8 bytes of memory onto the heap, it will going to give me the same pointer from that particular heap, right? So in this way, so currently tkh bin is empty because we have not freed any pointers. So we have just allocated, and we can see the allocated pointer over here. Okay. So the first 8 bytes, it chooses to store some metadata. Okay. For an example, we can see the 2, which states that the chunk size is hex 20, and the 1 is like the bits, which is so there are bits. Okay, for that, like is previous size is in use or not. Okay, so now coming back, so if I tap context, right, we can see we have allocated the pointer, right? So now if I do ni again, okay, so if I do ni, so now I'm trying to call the free, right? But I'm trying to do ni again, and as soon as we are almost coming to call the free pointer, right? So as soon as I do ni, and if you all do the v heap chunks, we can see that this pointer has been pointing into the tkh bin. So if I do tkh beans, tkh, sorry, beans, we can see we have freed one pointer, and this is the address of the particular pointer. Okay, and which is of hex 20. So minimum size of data which the, what do you call it, it's the heap allocates is 20. So if you are trying to allocate more data than hex 20, so then heap will going to allocate more than that. Okay, the minimum value it allocates is like the hex 20. So now what we can do is that now we can try to override some value onto this return address. Okay, oh yeah, onto the return address. So what will happen is that the next time whenever you try to allocate some data onto the heap, it will going to point to the allocated data onto the that particular memory address, right? So what I'll do is that I'll just try to do ni, and then we can see we are trying to copy now data a on in the pointer one. So let's see what will happen over here, and we can see that will come till the move instruction over here. Okay, and yeah, if I do visualize heap chunks, so we can see we have overwritten some data over here, but we need to overwrite until this particular pointer. So next time whenever it points, it should point to my particular address, right? I hope you all are getting this because I'm also trying to learn these things, right? So there might be a bit confusion between us. So now next what I'll do is that I'll just press continue. The program will going to exit. Okay. Now if you all want to learn more about this, I can give you a context called as there is a heap 101. Okay, oops, sorry. It is called as how to heap. Okay. So there is a nice GitHub repo created by the shell space. Okay, so over here you will get all the context and how to heap, so education to the heap exploration, right? First see, then fast bin, package bins, so there are many other like contents available, house of spirit, house of orange, many other stuffs. Okay, so now what I'll do is that I'll just try to build this up, then go to my root folder over here. So now we need to write some data onto this text. So we could overflow it, right? So what I'll try to do is that now I'll try to write some 8 bytes of data. Okay. So more 4, 1, 2, 3, 4. And then again, what I'll try to do is that I'll try to allocate again the pointer to malloc. Okay. Sorry. Again 8 bytes. So now let's see what did this happen. So I'll just try to compile it over here. Then again try to link it with my fetch elf. Then again come to this binary. Okay, so click it on start, then click do ni. So now as you can see, allocated this some data onto the heap, right? Now again do ni next instruction. Now I'm trying to free out the pointer. So if I do p page beans, you can see it has been pointing to this particular memory address, right? Now what I'll try to do is that now I'll try to write some data using the stir copy functions. Okay, so I'll just try to do that. Oops, sorry. If I do visualize heap chunks, you can see we have overwritten some data. Okay, the hex 41, 41, 41. Okay, and if I do ni again, and we can see we are trying to do a malloc again, right? So if I do visualize heap chunks, so now we can see the TK's bin, the next address is pointing to the hex 41, 41, 41, 41. So now the attack vector comes over here. Okay, so what we can do is that instead of writing the hex 41, 41, we can give the address of like, what do we call this? We can give the address of malloc of GOT address, and then we can overwrite the GOT address with the win function address. Okay, and in this way we can get the address of the win function, and then we can execute the particular win function whatever we want to do. Okay, so I'll just come over here. Meanwhile, let's see. I'll just try to do integer win, then I'll just try to write, or even okay, right, fine. 0, and then I'll try to do like pw font, and then like 1 2 3 4 5. I'll give 6 bytes, and then slash and that, and then return 0. Okay, so now before printing this, I'll just try to print the address of the bin function, right? But still, what we can do is that we can try to disable the pi, right? So if we disable the pi, the addresses in the particular app will remain same throughout the code. So I'll just try to do this. I'll come into my Docker container hyphen no hyphen pi. Uh, I guess okay, it is just a warning. Okay, so if I try to come over here and give the patch, if I try to do one, oh sorry, check set hyphen file. So check sec is a utility in which we can check the permissions of we can check the permissions of a particular Elf binary, and there are like stack protections, like for example the stack canary, the pi which is position independent executable, then the nx which is the uh, which prevents executing the like shell code onto the stack and all. Okay, so file is equal to, I will try to give g1. Okay, so you can see the partial Trello stack canary is not there, nx is enabled, right? So the pi is been visible. So now we can easily try to get the address of the win, and from that win we can easily try to get that address, and then we can paste it onto that. Okay, so now what I'll try to do is that first I'll try to get the address of the pi, right? So I'll open my gdb over here. I'll do mm, is there any error? No, I guess info. Right. So now we can see. Okay, this is a bit weird. Okay, let me try to do this patch up. Uh, so now what we can do is that we can try to do info functions, right? Or we can click it on start, right? And we can click on disable disassemble. So we can see the address of win is right from this address. The hex 40 0577. So I'll just take the note of this address. Okay. Yes. So this is the address of the win function. So currently I'm trying to do the heap exploration technique. Okay. So this is the win, right? So I'm having this address. So now to show you all my previous exploit, how I used to do it, right? So what I'll do is that I'll just try to open my dot slash UAF2 and this UAF2.py, right? So this one. So in my previous exploit, I used to send the so I've used the font debug tools, right? Over here. So I'm opening that particular binary for that and creating the process out of it. And then I'm trying to send the GOT address, okay, the GOT address of the malloc. Then I'm trying to send it with the io.sendline, and after that it copies that GOT address onto that pointer one, and as soon as I do malloc of 8 bytes, the chunk from the GOT at that malloc address comes into that particular pointer. And after that, I write the address of the win function. And after writing the address of the win function, whenever I call the malloc, instead of calling malloc, it will going to call the win function. Okay. So I'll just try to show you all the exploit, right? So I try to go into my use after free work and Python 3 UAF py. So now you can see that we have got over here PW and PWM, saying that we have successfully exported the binary. Okay. So now to show you all the code, I'll also show you all the code over here. UAF test or see. So now you can see over here. First, I'm trying to print the pointer one address of that particular malloc, right? After that, I'm trying to pre it, and then I'm trying to read some data from STD input, right, from the console. And that data I'm trying to read it within my pointer, which is the dialing pointer, okay? And I'm trying to read it well. So here I'm sending the address of the malloc, the GOT address of pointing to the malloc. So after that, I'm trying to do pointer again, okay, pointer 2 and pointer 3. And in pointer 3, I'm trying to write this address of the bin. Okay, so first pointer will give me the chunk of the malloc, and then it will so as soon as I do pointer again, so now I'm currently pointing to that particular GOT address of the malloc. Okay, so whenever I'm at that particular malloc of that GOT address, I'm trying to beam copy the address of bin into that particular pointer. Okay, so I'm trying to override the GOT table of that malloc section with my bin address. So what will happen is that as soon as I do next time again malloc, instead of calling the malloc at the GOT address, it will be going to call the bin function, and in this way we can get the execution of the point. So currently I got execution 2 times because I've allocated 2 times. So even if you do like malloc 10 times, it will going to uh, call the win function 10 times. Okay, so we have hijacked the GOT table. Okay, so this attack is also called a GOT override attack. So this attack happens when you don't have permission. Okay, so like you there are no permission like overwriting GOT table attacks and all. So if I do check set onto this, I can compile equal to UAF test. Okay. Oh, sorry, I cannot modify this. So we can see that there is no railroad, means I cannot override to that particular GOT table. So railroad is like completely disabled. So anybody can read write to that particular GOT address. So there are many other ways in which how you can get right. So and there is a one more attack called as double free attack. Okay, so in which we try to dereference a particular memory 2 times, and from that we can get the execution of arbitrary execution of particular shell codes and all. So in this way, like we try to exploit the heap. So I will show you with this. Okay, fetcher. So I hope you all got to know about this heap, right? So like even if I what I'll do is that I'll show you all with debugging with that. Okay, so nv uf2.py. Now I'll turn on this gdb.attach. Okay, and I'll try to run this with sudo permissions because my font debug works only on sudo. Okay, so if I try to maximize this, so now you can see we're trying to read this. We are jumping back onto the line. So first we are trying to allocate malloc, right? 8 bytes. So if I do these heap chunks, we have allocated some bytes onto the stack, right? Again, if I do ni, so now I'm trying to malloc 8 bytes, okay, which is pointing to my malloc GOT address. Okay, so it is giving me the chunk from that particular entry. So if I do these heap chunks, and if I do t catch, okay, tac to catch wins, right? So now you can see this that this particular pointer is pointing to that malloc, right? So context. So if I do ni, so now I am trying to copy the address of bin onto that particular malloc address. So as you can see over here, right? Bin. So if I do ni next instruction, and then I'm trying to copy this bin from the source to the destination of malloc dot or at GOT address. If I do ni, and again if I do this, you can see I've written the address of bin over there. I guess it is. So the malloc is been already replaced by the bin address. Okay, so if I do ni again, and then as soon as I call the malloc, I'll get over here, I guess. Okay, I'll get it back into my console. Okay, so I'll do continue, 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 and the program has been posted. So if you see over here, we have got the execution pointing to the bin address. So in this way, like the heap attack works. I know that this video was not that helpful, but I tried to, or I managed to explain like what I was knowing in this video. Okay. So the Docker container I use because if you all try to do this on your host system, you all might get error because because there are some security patches in that particular glibc and the linker version, which stops you all to uh, override that particular pointers on the heap. So that was the point. Okay. Um, if you have any question, you all can just tell me. Right? Yesterday, I also streamed on this like uh, it was of like Android idea. So I was trying to create some bugs into the Android 9 version in user van mode. Okay, so that was not a bit successful part, but still I'll try to manage to do in upcoming videos. So tomorrow, what I'll do is that I'll give you all a detailed explanation on some of the overflows, and we'll also try to solve some of the bugs. Uh, we'll try to solve from this ecocity app. Okay, where is it? We'll also try to solve this one binary expression heap one. Okay, so tomorrow we'll try to solve this. Okay, so basically they have given an netcat instance, the binary file size and the source file size. So if you all want, we can have a look over here. Okay, just once. So if you see over here, we can see that there is a function called as a checkWin, two pointers, okay, and then some basic definition onto the stack. And then we can see print man, okay, nothing much big. Initialize function will be a very important because in this we are trying to copy the pico onto the input data, and in the save part we are again trying to allocate that data with the pico. The thing is that we just need to replace it with pico with this particular function called as pico, but the save part is been set to bico over here in the initialize function. So we just need to overflow the the heap and then just try to change this p to b. That's all. And then we need to call the case 4 function and the checkWin. So in this way, we can easily bypass the checkWin string comparison over here, and then we can, if we're going to print all the flag. Okay. So I hope you all got to learn something new. Okay. So we'll continue this stream tomorrow, and we'll try to exploit this particular binary, right? So I'm ending the stream. Okay. So till then, take care and stay safe.